we are now in a position where we can find all of the zeros of a polynomial function, both real and complex. And so we're going to start with a polynomial function, p of x equals x to the fourth minus 8x cubed plus 22x squared minus 28x plus 16. And so we're going to just start by just trying to find the zeros any way we can. We're going to list our possible. And we've got positive and negative possible. Well, we've got a 1 in front of the x to the fourth, and we've got a 16 over here, so we know that's 1, 2, 4, 8, and 16, and minus 1, minus 2, minus 4, minus 8, and minus 16. We're going to count the positive sign changes. That's 4, so the positives, there's 4 real, 2 real, or 0 real. For the negatives, though, we just need to rewrite this quickly. And it's going to change to x to the fourth plus 8x cubed plus 22x squared plus 28x plus 16 with no sign changes. So for the negative case, there's 0. That means I just single-handedly, with Descartes' rule signs, ruled out half of the numbers we have to look at. All of the real zeros we find have to be positive. Well, I'm a big fan of picking the number in the middle because if it does work, great. If it doesn't work, maybe it's an upper bound, and if it's an upper bound, then I don't have to look at the 8 and the 16. So I'm picking the 4 because it's got a good chance of knocking out the 8 and the 16. So we set up our division, 1 minus 8, 22, minus 28, and 16. We put a 4 on the outside. Gives me a 4, a minus 4, that's a minus 16, which is a 6, which is a positive 24, which is a minus 4, which is a minus 16. And notice that this worked. 4, in fact, works, and I found one of my positive real zeros, and I've done something else. Notice this number left over is a 4. It can't have an 8 or a 16. Those aren't factors of 4. So by finding 4, I ruled out the 8 and the 16. Well, all I have left are 1s, 2s, and 4s. It doesn't look like there's a very good chance of the 4 working again. So I'm going to pick the middle number. I'm going to pick a 2 this time. Let me plug down the 1. That gives me a 2, which is a minus 2. That's a minus 4, which is a positive 2, which is a 0, which gives me a minus 4. Nope, it gives me a 4. I'm putting these in the wrong order. Notice again, that is a 0, so again, that's a 0. And I found my second one. So I know there's not 0. There's 2 or there's 4, but all I have to do to look at the rest of this is to look at the x squared minus 2x plus 2 and recognize I can't factor that. That's as far as it goes. So we'll use the quadratic formula instead. Equals minus a minus 2 plus or minus the square root of minus 2 squared minus 4 times 1 times 2 all over 2 times 1, so 2 plus or minus the square root of 4 minus 8 over 2, 2 plus or minus the square root of minus 4 over 2, 2 plus or minus 2i over 2, which is 1 plus or minus I. So now I've found my 4 zeros. I have a 4, a 2, and a 1 plus I, and a 1 minus I. And I could write this, if I wanted to, this polynomial function, as x minus 4, x minus 2, x minus 1 minus I, and x minus 1 plus I. Or, if I don't like the imaginary numbers, I can write it as this, knowing that this breaks down as these. So this is how I can find all of my real zeros, using all of the things that we've talked about.